Welcome back to the OpenClaw Bootcamp. I'm Adhiraj and we are 8 days in. Your agent has personality, memory, and autonomy, but it doesn't have a rulebook. Doesn't know which tools to use when, how to delegate, or what it shouldn't do unsupervised. The agents file fixes that, gives it rules, priorities, tool policies, and delegation patterns. This is everything that makes your agent disciplined, not just capable. Today we're covering 4 things. First, what the agents file actually is, and how it differs from the soul, because people do confuse these two constantly, and putting the wrong content in the wrong file causes real problems. Second, the default template and the safety rails it's going to ship with, because understanding the starting point tells you what to customize. And third, the subagents. So what they are, how to spawn them, how to manage them, and the nesting and concurrency model that controls how deep the delegation can go. And fourth, the tool policies and the 3 independent security mechanisms that determine what your agent can do, where it can do it, and who can override those restrictions. So let's make this super concrete immediately, right off the bat. The agent's markdown file is the operating instructions for the agent and how it should use memory. That's the official definition, and the key word here is operating. This file governs the mechanics, not the personality. It breaks down into 3 key areas. First, the operating rules, which are your priorities, workflows, escalation procedures, and how the agent should handle specific situations. Safety defaults, which are the guardrails that prevent your agent from doing something destructive without being asked. And then memory guidance, which tells the agent how to read memory at startup, what order to check files in, and what's worth remembering. The distinction from the soul matters here. Soul is where your agent's voice lives, tone, opinions, and boundaries. Agents is where your behavioral mechanics live, what to do, when to do it, what tools to use, and how to delegate. You want to keep the agent's file for operating rules and keep the soul for the voice, stance, and style. If you're writing something about how your agent should sound, it goes in the soul. But if you're writing something about how your agent should behave, it goes in the agent's markdown file. The file is going to live on the file path shown on the slide. It's the same workspace directory as the soul and memory markdown files, and the same markdown format. What's different here is that the agent sits at the Bootstrap injection order. So when a session starts, OpenClaw injects all your workspace files into the system prompt as project context, and the order is this: agents first, then soul, then tools, identity, user, heartbeat, Bootstrap, and finally memory. The agent's markdown file is literally the first thing your agent reads. It's set to behavioral frame, before personality, before identity, and before memory. Everything else builds on top of the operating rules. The loading rules here are the same as all of the Bootstrap files. The blank files are going to get skipped, the oversized files get trimmed with truncation markers, and the missing files receive marker lines, so the agent knows that they should exist, but they don't. This is the slide to screenshot if you take nothing else from today. The agents file handles operating instructions, rules, and memory guidance. The soul handles persona, tone, voice, and boundaries. Agents is loaded in all sessions, including the subagents. Soul is loaded in normal sessions only, so the subagents never see it. The agent's markdown file's content is super mechanical, so it's workflows, priorities, and tool usage rules. The soul content is expressive, so short beats, long, sharp beats, vague, the stuff that makes your agent sound like someone specific. And that loading difference is the critical architectural point here. When your main agent spawns a subagent to do the background work, that subagent only receives the agents and tools markdown files. All the other Bootstrap files are filtered out to keep the subagent context very small, so your operating rules reach everywhere, every session, every subagent, every background task. But your personality, your identity, and your user preferences, those stay in the main session where they belong. OpenClaw ships a default agents markdown template that the docs describe as a personal assistant variant. You don't have to use it, but it is worth understanding because it's going to establish the baseline that your agent starts from. The template defines 3 safety defaults. First, don't dump directories or secrets into chat. Your agent should never paste file trees or credentials to a conversation. Next up, you don't want to run destructive commands unless explicitly asked. So no deleting files, no overwriting data, no irreversible operations without confirmation. And third, don't send partial or streaming replies to external messaging services. So what does this mean? If your agent is composing a response for Telegram or WhatsApp, it should send the complete message, not just stream fragments. The template is also going to specify a startup read order. When the session begins, the agent reads the soul first, then the user markdown file, then today and yesterday's daily memory files, and finally the memory markdown file or the legacy memory.markdown as fallback. This gives the agent a structured way to load context, which is personality first, user preferences, then recent memory, and then long-term memory. So what are subagents? Subagents are one of the most powerful features in OpenClaw, and they're governed directly by what you put in your agent's markdown file. So you really do want to understand this slide. A subagent is a background agent run spawned from an existing agent run. It operates in an isolated session with its own context window and its own token usage. It receives only the agent's markdown and the tool's markdown as Bootstrap context, and when it finishes, it announces a summary or result message back to the requester's chat channel. The main agent doesn't stop, right? It keeps working while the subagent runs, and spawning it is non-blocking, and you get a run ID back immediately. Think of it like you're delegating a task to an assistant. You say, okay, go research this topic and report back. The assistant's going to go off, work independently, and when they're done, they're going to walk back in and give you a summary. The main agent doesn't wait around, and the subagent doesn't have access to the full conversation history or your personal context. It just has the operating rules from the agent's markdown file and the available tools from tool's markdown file and the task that you gave it. Now, there are two ways to spawn a subagent. From chat, you can use the /command /subagent spawn followed by the agent ID and the task description with optional flags for model and thinking level. Programmatically, the agent itself can call the session spawn tool with the task parameter, which is how agents delegate work autonomously during complex workflows. Once the subagents are running, you have a full management toolkit. The /subagents list shows all your current runs. Subagents kill terminates a specific run or all of them. Subagents log shows the output, and you can limit how many entries or filter to just tool calls. Subagents info gives you the metadata, so the model, runtime, and token count. Subagent send lets you message a running subagent with additional context. And subagent steer gives it direct guidance to change course. One important behavior here is that running /stop in the requester chat cascades to abort all subagents and their nested children. So if something goes wrong and you want everything to halt immediately, you can use that one command to stop the entire delegation tree. Now, subagents can nest, but there are strict limits. At depth 0, you have the main agent, which can always spawn subagents. At depth 1, you have subagents, which can only spawn their own subagents if the max spawn depth is set to 2 or higher. This is the orchestrator pattern where a subagent acts as a coordinator and delegates further. At depth 2, you have workers, and workers can never spawn. The maximum nesting depth is 5, but the docs do recommend 2. The defaults are always conservative by design. So max spawn depth defaults to 1, meaning the subagents can delegate further unless you explicitly enable it. Max children per agent defaults to 5, so a single agent can have at most 5 active subagents. Max concurrent defaults to 8 across the whole system, and archive after minutes defaults to 60, so completed subagent sessions get cleaned up after an hour. You can configure all of this in OpenClaw.json under agents default subagents, and if you want the orchestrator pattern, like where your main agent spawns a coordinator that spawns workers, you want to set max spawn depth to 2 and adjust max children per agent and max concurrent based on your workload. Tool policies are the access control layer that determine which tools your agent can actually use, and the fundamental rule is super simple. Deny always wins. If the tool appears in both the allow list and deny list, it's denied. There's no exceptions. The system uses a cascading model, as I mentioned before. You start with base profiles, then the provider-specific profiles, and then the global allow and deny lists, and then finally, Sandbox-specific restrictions. Each layer can tighten what's available, and deny at any layer blocks the tool everywhere below. For convenience, the tools are organized into groups. Group runtime covers exec, process, and code execution. Group FS covers read, write, edit, and apply patch. Group sessions covers session management. Memory covers search and retrieval. And web covers web operations. You can allow or deny entire groups instead of listing individual tools. Per agent tool policies go inside your OpenClaw.json. Under the agent's config, you can set an allow list, a deny list, or both. A non-empty allow list automatically blocks anything not inside it, which is how you create a restricted agent that can only read files and list sessions but can't write, edit, or execute anything. Tool policies are just one of the 3 independent security mechanisms, and understanding how they work together is super essential for running agents safely. Sandbox determines where these tools are going to execute, so inside a Docker container or on the host. You can set the mode to off or non-main, which sandboxes everything except the main agent, or all, which is going to sandbox literally everything. You configure that globally through agent's default sandbox, or per agent through agent. The tool policy determines which tools are available. This is the allow, deny cascading system we just covered. It's the hard stop, so if a tool is denied by a policy, nothing can override it. The /command /exec cannot bypass a denied exec tool. Elevated is the escape hatch. So /elevated_on runs exec commands outside the sandbox, and /elevated_full skips exec approval prompts entirely. It's gated by tools elevated enabled and tools elevated allow from with the provider key, and can also be configured per agent through agents list tools. Elevated only affects exec, so it doesn't grant additional tools or override your tool policy. These three operate independently. So Sandbox is about where, tool policy is about which, and elevated is about who can override. They don't conflict because they control different dimensions. Now, once you understand the agents markdown file, subagents, and tool policies, you can start thinking about multi-agent architecture, so running multiple distinct agents with different workspaces, different configs, and different roles. Each agent in OpenClaw is 3 isolated components: a workspace with its own agent's soul markdown and other files, a state directory called agent directory that holds auth profiles, model registry, and agent-specific state, and a session store at OpenClaw agents ID/sessions. One super important note here is you never want to reuse the agents directory across agents because it causes auth and session collisions. Routing determines which agent handles which conversation, and it follows a deterministic precedence. The order is peer, then parent, then guild ID plus roles, then guild ID, then team ID, then account ID, then channel level, and then finally fall back to the default agent. If multiple bindings match in the same tier, the first one in the config order wins. This is how you set up one agent for Telegram, another for Discord, or route specific users to specific agents. Since the agent's markdown file is injected every session and every subagent session, keeping it lean directly affects your costs across the board. If your agent's markdown file is bloated, every interaction and every subagent spawn pays that tax. The good news is that OpenClaw gives you 3 commands to inspect exactly what's happening. /status gives you quick context window, fullness assessment, so how much of your available context is being used. Context list shows you every injected file with raw versus injected sizes and indicates if truncation occurred, so you can see exactly how much each file contributes. And the context detail gives you the per file and per tool breakdowns for a full audit. Remember that the subagents already skip the soul, identity, user, heartbeat, and bootstrap markdown files to stay lean. The agents file is one of the only 2 files that they receive, so keeping it concise benefits your delegation costs disproportionately. 4 things before day 10. First, you want to review your agents markdown files, open up your OpenClaw workspace agents markdown, and then read through whatever's in there. So either the default template or whatever you've customized. Identify the 3 safety defaults and startup read order. If you haven't touched it yet, this is a good time to understand that baseline. Second, you want to spawn your first subagent. So run /subagents, spawn main, and then you can say summarize my last 3 daily memory files in the chat. Then you want to use /subagents list to watch it run, and then subagents log to read the result when it's done. This makes the delegation model tangible, and you'll see the isolated context, the announce mechanism, and the token usage firsthand. Third, you want to inspect your context. So run /context list and /context detail to see exactly how much each Bootstrap file contributes to your token usage. Pay extra attention to your agents markdown file specifically, since it's the one file that hits every session type. Fourth, you want to add one custom operating rule to your agent's markdown file, something specific to your workflow, like always write code in TypeScript, summarize articles before responding, or never use the exec tool without confirmation. Then go ahead and test it in a new session to verify that the rule takes effect. Your agent now has rules, guardrails, and the ability to delegate work to background processes. It's not just capable, but now it is disciplined. Day 10 is tools and skills, so extending what your agent can actually do beyond the defaults. If you want hands-on help setting any of this up, consult with me at adhivarjungla.com. If this series is helping you, subscribe so you don't miss it. And with that, I'll see you on day 10.